Okay, now we're going to start talking more particularly about these hyperbolas and the variations that you can have. Okay, so we have two general variations. Okay, the x squared over a squared minus y squared over b squared equals 1, and the other variation, okay, x squared, the other variation down here is y squared over a squared minus x squared over b squared. Now, okay, unlike the ellipses, there's no mandate that the a term be larger than the b term. Okay, and obviously the distinction here is one set opens up left and right, okay, and is effectively symmetric about the x-axis. The other set opens up and down and symmetric across the y-axis. Now, very easy to distinguish those, okay? In most cases, in the general form, the first variable listed here will tell you the direction, so since x is listed first, it tells you the direction. Y is listed here first, that tells you the direction. But that's kind of a poor way of determining it because it's not always going to be in that form. The other thing that is the best way, I suggest, knowing the distinction, is that we notice that the set opening up left and right with symmetric to the x-axis has x-intercepts, no y-intercepts. And if you go right to the opening equation, okay, and you try to find y-intercepts by setting this equal to 0, by setting x equal to 0, you set x equal to 0, you're going to be trying to find the square root of a negative for y. So that's going to be a red flag telling you that there's no y-intercepts, and therefore it's going to open left and right. Same deal over here, okay? Same deal over here. Go to this equation and try to find x-intercepts by setting y equal to 0. Setting y equal to 0, obviously, you're going to have x squared equals negative b squared, which will never happen, and therefore red flags and says, oh, no x-intercepts, must be opening up and down, okay? Now let's look at this, and I've put there, along with this video, the link to the Desmos file. Okay, there's 3 varying Desmos files. This is the Desmos file, which is opening left and right. So I think it's Hyperbolas X, I think I called it. So here we go, okay? One thing for sure, again, no requirement that X be larger than B. I mean, that A be larger than B. As you can see here, rolling out the B value, okay, there's no problem with that. It's still going to open up left and right, as it were, okay? Now, the thing is, okay, now here, and in fact, A and B can be both the same, as is the case here, all right? The nicety here is finding what we call the asymptotes, okay? So there's the asymptotes, the guides towards which the function drifts, okay? And they're simply in this orientation, okay, it's going to be, okay, the two lines, get that out of there, sorry, okay, the two lines, y equals, well, let's look at one at a time, y equals b over ax, that's going to serve as this one asymptote, as you can see, drifting along, okay, and again, regardless of how a and b change, that y equals b over ax will always be the asymptote, okay, right there, all right, okay. The other asymptote is the opposite of that, is here, okay, and very often the easiest way to sketch these things is to sketch it in with the asymptote, okay. So the asymptotes are sketched in, and there you have it, a nice clean graph, okay. We'll show you in the subsequent video that how you can build the box there, which defines that, the diagonals of which define that those asymptotes. Here's your focus, okay? Your focus, of course, is on, again, what we'll call the major axes here, okay? And the focus is simply by a Pythagorean identity. C is equal to a squared plus b squared. Okay, so, and here's your focus point right there, and right here. Okay, and then you have your vertex points, which are indicated right here, which are your A values. So with A equaling 3, okay, there's my vertex points, okay, and then so that distance between that vertex point and the focus is what we call the focal length. Okay, that's the focal length. All right, and the focal length is going to, as you can see, drift further away from the vertex point just by this Pythagorean relationship here. Okay, but the more broadly open that hyperbola gets, the further that point drifts away, and of course the more squashed, if you will, that hyperbola gets, the closer that that point, that focus point, drifts towards the vertex. Okay, I'm going to put on hold right here for a minute and come and do the other one. Okay. Okay, so we're back, and here's our summary sheet on the hyperbolas opening left and right. Again, easy to determine by where the intercepts are, the items to remember based on the equation. Of course, number one is if it's not in this form, if it's equal to something other than 1, then we have to divide through that to get it into this form and identify our A and B terms. Okay, having that in place, we can find the using the simple Pythagorean identity here, find the value of C, and therefore indicate the coordinates of the focus point, and then also with the A and B indicate the equations of the asymptote lines. Okay, we next turn our attention to the hyperbola oriented vertically. Okay, and as is illustrated here, and as we will illustrate with the Desmos. Okay. And of course, how do we know whether it's if it's oriented vertically is because, again, we're going to try to find the intercepts, and if we're going to try to find x-intercepts here by setting y equal to 0, we're going to be red flagged, asked to take the square root of a negative, so that's going to say there are none. So by default, then we're not going to have any x-intercepts. It's going to open up then vertically. Okay, we have here our hyperbola of that form right here. Okay, we're going to illustrate where we're getting everything very simply. Okay, again, this is one you'll have available to you. Again, the foci given by the formula square root a squared plus b squared are going to be, in this case, on the y-axis because of the orientation. Again, no mandate here that A be bigger than B. No such mandate. Again, the broader this hyperbola gets, the further our focus drifts away from the vertex here, and of course the vertex, as you can see, is always indicated by that A value. All right, so that's nice and convenient right there. All right, the axes, seeing the asymptote lines, okay, in this arrangement are going to be the lines y equals a over bx, and negative a over bx. Okay. A over bx and negative a over bx, and we'll show you in a subsequent video when we build a box around this that it's actually why we have that why we have it as a over bx for the orientation vertically and b over ax for the orientation horizontally. So you'll see that, and you should ask that question right now. Okay, so there again, you'll have this there for, in the link, so you can see for yourself the alterations in A and B and the impact it has on the positioning of those components of the graph, mainly the focus and the asymptotes. Okay, so we're going back to our summary table here for the orientation vertically given by the equation of this form. Our focus is found the same way. However, our focus is going to be oriented on the y-axis. Okay, and our asymptotes are the form a over bx and negative a over bx. Okay, and I think we'll stop it at that. Okay, I think we were going to stop